Hi students, welcome back. Today we are going to learn about polymers. The small molecules used to synthesize polymers are called monomer. A polymer is a large molecule made up of many monomers repeating units. The chemical reaction in which small molecules are joined together is called polymerization. Let's look at classification of polymers. So polymer can be classified based on origin of source, structure, molecular process, and type of polymerizations. So for STPM, you have to know natural polymers, synthetic polymers. Semi-synthetic is not important. Then linear polymers, branch chain polymers, cross-link polymers. Next, elastomers, thermoplastics, thermosetting polymers. Okay, so there are two types of polymerizations and forms emission polymers and condensation polymers. So polymers can classify based on origin of source. We have natural polymers, synthetic polymers, and semi-synthetic polymers. Semi-synthetic polymers is not so important. So we stress on the natural polymers and synthetic polymers. Natural polymers are isolated from natural materials. So example, we have rubber, more important one. Then synthetic polymers, we can synthesize them from the raw molecular weight compounds polymers. Example, we have polyethylene and nylon terephthalate. Semi-synthetic is derived from the naturally occurring polymers by chemical modification. Example, we have rayon. So based on structure, we have linear polymers, which is molecule formed from the long chains without bunches. Then bunch polymers having bunches. Cross-link polymers have interconnection between the chains. For example, we have the rubber, organized rubber. Network polymer is not important. Network polymer is the cross-link polymers that included numerous interconnection between the chains. For polymers classified based on molecular process, we have elastomer, fibers, thermoplastics, and thermosetting polymers. So for STPM level, we stress on the elastomers, thermoplastic, and thermosetting polymers. Now based on the type of polymerization, we have addition polymerization and condensation polymerization. So for addition polymerization, we have carbon rubber bond. So the rubber bond is broken and form the single covalent bonds. Then monomers are joined up into a large polymer chain. For condensation polymer, we have monomers that have two functional groups. For example, dicarboxylic acid or diol. So the water molecule will be eliminated during the polymerization process. Polymerization reactions which involve one type of monomers are called homopolymerization processes. Examples of homopolymers are polyethylene, polychloroethylene, or PVC. So homopolymers have one type of monomers. Polymerization reactions which involve two or more different types of monomers are called copolymerization processes. Examples of copolymers are terylene and nylon. So homopolymers have one type monomers. Copolymers have two types of monomers. So we have two types of copolymers. If the monomers arranged in sequence, so we call alternative copolymer. If the monomers are joined randomly, we call random copolymers. Okay, now let's look at thermoplastics. Plastic like polyethylene, PVC, nylon, without crosslinks, soften when we heat them, they can be remolded to make new shapes. These are called thermoplastics. Thermoplastic does not have cross-linking between the chains, so when heat, weak forces between polymer chains easily broken by heating, polymer can be molded into a new shape. As for thermosets, they have to be molded into shape when manufactured. They do not soften and eventually decomposes on strong heating. Cross-linked polymers do not usually soften on heating and are called thermoset polymers. Thermosetting plastics are useful when resistance to heat is important. For example, is saucepan handles. So thermoset has extensive cross-linking between the polymer chain. After heating, strong covalent bonds between polymer chains cannot be easily broken. Polymers keep shape on heating. So in thermosets, bonds prevent chains moving relative to each other. So they are permanently very hard and rigid the first time heated, insoluble and good heat resistance. Example, we have epoxy resins, phenol resins, and saturated polyester resins, and vulcanized rubber. An elastomer is a material that can rapidly recover its original shape after being deformed. They are typically amorphous polymers that have a small degree of cross-linking. Example, we have natural rubber, spandex fibers, and chewing gum. Fibers is not important, but for extra information, fibers are generated when certain polymers are heated, forced through small holes and then cooled. The resulting fibers exhibit crystalline regions that are oriented along the axis of the fiber, which endow the fibers with significant strength. Example, we have nylon, nacon, and polyethylene, all of which have the appropriate degree of crystallinity to form fibers. And now let's look at addition polymerization. The addition reaction in which monomers with carbon-carbon double bond are joined together by single covalent bonds to form a large molecule polymer without the loss of a small molecule is called addition polymerization. So here show the example of addition polymers. Okay, so example we have polypropylene, polychloroethene, PVC, polyphenylethene or polystyrene. So the monomers is in the bracket of the name of polymers. So for polypropylene, the monomer is propene. Okay, the chemical equations, you write N mole of propenes, reacts and form the polypropylene. So the polymer have bracket N. So the repeating unit is in the bracket. Uses of polypropylene is to produce plastic bottle, carpets, lab equipment. Polychloroethene PVC, the monomer is chloroethene. Chemical equation, N mole of chloroethene reacts to form the polychloroethene. Repeating unit is in the bracket. So the uses to produce raincoats, pipes and curtains. Polyphenylethene, polystyrene. Monomer is phenylethene. Chemical equation, N mole of phenylethene form the polyphenylethene. The repeating unit is this. The uses to produce foam packaging with disposable cups and refrigerator liners. Okay, so Ziegler-Natta catalyst. So the catalyst is named after the scientist Carl Ziegler from Germany and Giulio Natta, Italy, and they have won the Nobel Prize in 1963 for the finding of catalyst. So this catalyst is used in the reaction addition polymerization. The reaction will require much milder conditions, and the catalyst consists of a mixture of titanium tetrachloride and trialkyl aluminum. So it's a catalyst for addition polymerization. So the reaction will produce stretch-chain polymers. In contrast, polymers produced by free radical mechanism have many branches. The polymer form is called isotactic or hidden polymer. So for addition polymerization using the Ziegler-Natta catalyst, will produce stereospecific polymers. For example, isotactic or syndiotactic polymers. We will look at the next slide. What is meant by isotactic, syndiotactic, and atactic polymers? Okay, atactic polymers has the alkyl groups randomly disposed on either side of the stretched carbon chain. Okay, so it's randomly arranged, so it's not in sequence. It's non-crystalline, low softening point, and has poor mechanical properties. So the atactic, the A is stand for without, tactic is a big words, tacticos means order, so without order, so the alkyl group is not in order. Stereospecific polymers authenticity. Okay, so for example, this one isotactic, the alkyl group all arranged in one side of the carbon chain. So for syndiotactic polymers, the alkyl group is alternate side of the carbon chain. So isotactic polymers, the alkyl groups are all on one side of the straight carbon chain. Syndiotactic polymers, the alkyl groups are alternates regularly from one side of the straight chain to the other. So syndio stands for two different ones together. So hydrogen alkyl group together, hydrogen alkyl group together. So this is an example of straight chain polymers and bunch polymers and cross-linked polymers. So section polymers, which is produced by the Ziegler-Natta catalyst. Okay, so it will form high-density polymers, are often quite flexible. Van der Waals forces and hydrogen bonding are the two main types of interaction between chains. Example, we have polyethylene, Teflon, PVC, and polypropylene. Bunch polymers, inability of chains to pack very closely together. These polymers have lower densities. These bunches are usually a result of side reaction during the polymerization of the main chain. So most linear polymers can also be made in bunch form. Cross-linked polymers, adjacent chains attached via covalent bonds. Generally amorphous polymers are weak and cross-linking at strength. Vulcanized rubber is polyisoprene with sulfur cross-link. Now let's look at condensation polymerization. The condensation reaction in which monomers with two functional groups react to form a large molecule polymer and eliminate in small molecules such as water, ammonia, or hydrogen chloride. This chemical process is called condensation polymerization. The terylene is an example of condensation polymer. So the monomer we have ethane 1,2-diol and the benzene 1,4-dicarboxylic acid. So the polymerization equation, we have N mole of ethane 1,2-diol reacts with N mole of benzene 1,4-dicarboxylic acid and form the terylene. So ester is formed and it's a condensation reaction. N mole of water is eliminated. So for the polymer, you have to write the bracket and repeating unit, you just copy the structure in the bracket of the polymer. Uses of terylene is to synthesize fiber in manufacture of yarn and textiles. Well, you can see here, water is eliminated during the reactions and the ester link. Finally, we have nylon 6, another example of condensation polymer. So the 6 stands for the carbon, number of carbon. So the monomer we have hexane 1,6-diamine and hexane 1,6-dioxide. So 6 carbon in the amine and 6 carbon in the carboxylic acid. So the polymerization equation, we have the N mole of hexane 1,6-diamine plus N mole of hexane 1,6-dioxide acid reacts and form the nylon 6, and it's a condensation reaction, so water is removed. So the amine donate the hydrogen and the carboxylic acid donate the OH. So one water molecule is formed. So when we have n mole of hexane 1,6 like amine and n mole of hexane 1,6 like acid, so n mole of water is formed. So the amide ring is formed in the polymer. You see the amide ring. Okay, the repeating unit also copy the structure in the bucket. Uses of nylon 66 is to produce synthetic fiber in manufacture of cloth and twine. So this is a twine. That's all for the presentation today. Thank you for watching.